Now let us see this Froude's model's law, and as we have seen the relationships between the velocity ratio and the discharge ratio, the force ratio, and let us continue the some more ratios. As we have seen Froude's model law, V divided by root Gy is equal to 1, or this Froude's model law, if V by root Gy is equal to 1, this is V by root Gy is a Froude's number. If the Froude number is equal to 1, this is nothing but the critical flow. So accordingly this number we can write this model, and we have discussed the Vm by Vp is equal to Vr is equal to root Lr or Lr to the power of half, and the discharge ratio Qr is equal to Am, that is Ar into velocity ratio, so Lr square into Lr to the power of half, that is Lr to the power of 5 by 2, and the force ratio from this one, this is Fr is equal to Lr cube. Now the next one, the power ratio. This power ratio is equal to, power is equal to work by time. Power is equal to work by time. Work is equal to force into distance moved divided by time. Now we can see this particular one. The power ratio PR is equal to, this is the force ratio Fr. This is not the Froude number, this is the Froude number. This is the force ratio into distance by time, that is nothing but velocity. So this is, now we can express the power is equal to the force into velocity, and accordingly this force ratio is equal to, this power ratio is equal to force into velocity, and the force ratio Fr is equal to Lr cube, and Vr is equal to Lr to the power of half, and power ratio PR is equal to Lr to the power of 7 by 2. Now let us see the time ratio. Tp by Tr is equal to Tp by Tm. Now, as we know, the velocity is equal to distance by time, and this particular one we can write this velocity is equal to L divided by T. So the time is equal to L divided by velocity. So this is Lr divide this particular one, Tr is equal to Lr divided by Vr. So this is Lr divided by Vr is equal to Lr to the power of half. So this is Lr into Lr to the power of minus 1 by 2. So Lr to the power of half. So the time ratio Tr is equal to Lr to the power of 1 by 2. And we can also write this one as root Lr. So the acceleration ratio, now we can compute the various ratios. You can see here, these particular ratios all derived from one particular one. Vr is equal to Lr to the power of 1 by 2. So this Lr to the power of 1 by 2, we got it, this velocity ratio, from the Froude's model law. And the Froude's model law states, as I mentioned here, the Froude number in the model is equal to Froude number in the prototype. With the help of this particular Froude model law, we have derived the various scale ratios and various force ratio, velocity ratio, the discharge ratio, the power ratio, time ratio, and the last one is an acceleration ratio. This acceleration ratio AR, it is nothing but the AR is equal to the AM by AP, and accordingly we can write this acceleration in terms of the velocity by time. So this velocity by time, acceleration is equal to velocity divided by time. Now this acceleration we can write AR is equal to VR divided by TR. So VR, the velocity ratio, is equal to LR to the power of half, that is root LR divided by the TR root LR, so is equal to 1. So thus the acceleration ratio is equal to 1, the number. This is the, now with reference to the Froude's model law. So we have used all these particular equations in a very simple way. One is the Froude's model law and the force, that is the Newton's second law, force is equal to mass into acceleration. With the help of all these particular formulae, we derived the various ratios, and these ratios can be used to calculate in the reality the various model, either in the model or in the prototype, the quantities. Means, as I told, the various applications of these particular models, especially the open channel flow, and as well as this particular, the discharge, the spillway, is the best example to analyze this particular Froude's model. Now we know this particular one, especially the discharge and the power and the force, and these are very commonly used in our civil engineering, the examples. That means whenever you say the particular flow, that means, as I mentioned, the two things, one is with reference to the discharge, that means the actual discharge, that is nothing but the discharge in the prototype, and the theoretical discharge or the discharge in the model, and this discharge in the model and the discharge in the prototype can be explained simply by the discharge ratio QR is equal to QM divided by QP. So now with the help of this particular equation, this is all expressed in terms of the QR, the discharge ratio is in terms of LR to the power of 5 by 2. So this particular value, if you see this particular discharge ratio, LR to the power of 5 by 2, and this is a very simple thing, the model and the prototype, and either the dimensions of the model, this is the model, this is the prototype, the actual structure, and you can designate all these dimensions, the designate or manufacturing the model by using the scale ratio values. And this model and the scale ratio terms are very useful in computing if the discharge in the prototype or if the discharge in the model and this the discharge in the prototype QP and this QM. Now using the scale ratio as I told, LR is equal to LM by MP. That means here you can see this particular one. This is GY. That means this linear dimension, the scale ratio LP by LM. You can compute the LR value with the help of these ratios of these dimensions. That means you are fixing the scale ratio. That means you can choose the value of a scale, that means the dimension. Suppose if the actual structure is 10 meters, you choose an appropriate scale. Is it a 1:100 or 1:1000? Whatever the value, you can choose it. According to the scale ratio, you can calculate. If you want the QP should be how much, you can perform the test on the model. In the model, once you fix the discharge and how much discharge it is able to allow through the spillway section, and using this particular value of the scale ratio you can calculate what is the discharge in the prototype. So that is the main application. And similarly, if you observe the power, again the power is equal to LR to the power of 7 by 2, and this power also in the same way, power in the model and the power in the prototype. Whenever anything, if you are calculating the work, power, force, discharge, velocity, the time, acceleration, any parameter can be, you can see all these parameters is a function of LR cube, LR to the power of 7 by 2. So this is equal to LR to the power of half, and this is equal to 1. So now all these ratios are only the function of the scale ratio. This scale ratio, once you define, that means if this is the dimension in the model is equal to 10 times or 100 times, that is the dimension in the prototype. This is what the scale ratio, or the ratio of the two dimensions with reference to this particular Froude's model law. Hope you understand what is the Froude's model law, and we just used the Froude number concept, that is the Froude number in the model is equal to Froude number in the prototype. So just using this particular one, V by root Gy to the model is equal to V by root Gy to the prototype. So just use this particular model law, and we have evaluated what is the reality and application of this particular model. So hope you understand what is this particular Froude model and its real time, what is its application, especially with reference to spillway or with reference to open channel flows in the civil engineering.